Okay.
There were two things to do, and it wasn't very clear, but I'm going to integrate them for the next round.
Oh, that'll be nice.
Mm-hmm.
Yeah, unfortunately, we have more coming up, so
Yep.
anybody who wants to do it hands-on will have the opportunity.
What you might want to consider, Ken, is to, by default, include the kit, and then if they don't need it, there's an opt-out.
Yeah, make a button for it then, right, in the application. I'll do that. Remind me of that, Andy. I'll make a note. I'm not going to rely on Andy. I already rely on Andy way too much.
Yeah, and the real joke here is that Andy is fundamentally scatterbrained because he's always basically obsessing on code and can't remember anything else like tying his shoes.
Right.
Ken, this is Randy. You saw the email, I got the kit, and after about 11:30, 12 o'clock, my wife said I had to go to bed.
You're not alone, Dr. Rubenstein.
Bed? What's bed? Isn't this still Thursday?
This week went by very fast, didn't it?
And very slow.
No. Yeah, that's true.
Yeah, one of the things that you didn't mention when you said for the cybersecurity we would need a second microbit was the fact that you can't always use the same computer to talk to that second microbit. You have to use another one. I was able to see both units connected to my USBs, and I was able to program one at a time, but it was clunky. I had to disconnect and then reconnect and whatever.
So did you try opening two browser instances?
Oh, I didn't have to. I had a second computer, so I just defaulted to that one.
Okay.
But I guess that would have worked as well.
Yeah, it's still a little clunky. I have some extra things to show you about that in about 40 minutes.
Cool. But Randy, I completely understand what you're talking about when you talk about the 1230. It turns out that when we are absorbed, time does not mean anything. It's just getting something done. And when we're not absorbed, time takes forever. So it's either infinitely small or infinitely long periods of time. And it depends on other people to tell us whether we've done too much or too little or whatever. But I hear you, Randy.
Yeah, and my wife is not opposed to telling me. All right, did you hear what she said? She said, especially when I make her come in and watch everything I finished.
Yeah, but when you have the robot deliver coffee to her tomorrow morning, then she'll appreciate all the work you've done.
When I finally rigged up a really neat project where this robot was picking up colored balls or cylinders, and I showed it to my wife, she said, yeah? What? It took me all weekend. I think it's the coolest thing I've done in a long time.
In my house, the response would be, oh, good, then maybe you can teach it to pick up your laundry.
You know, that's kind of an interesting subject too, because imagine what it would take to have a robot actually fold laundry. It's something that we find to be completely simple and don't really have to think about much, but in terms of the resources you'd have to devote to making a robot fold laundry, it's kind of one of those big multi-university type projects.
Yeah. Well, and you know those those $30,000 robots that they have with the arms and does everything that, you know, a few colleges have and they can program. She said, "Well, I thought it was going to be one of those." Not so much, dear.
Hey, Ken.
Yeah.
I have a question. I put it in the comment too. I was the one who sent you information about the continuing education points. Do you guys
Yes.
have that, or?
We could write you, give you a certificate, and we haven't been sending them out, but we'll do it upon request. So if you send me an email,
Okay.
and then be sure to include your address, we'll get you that certificate. And it's a 1-page skills certificate.
Can you just shoot it over email?
Sure, yeah.
Okay, that'd be perfect.
Great. Great. That will be helpful for me too.
Yeah. So I'll make that a housekeeping agenda item. I'll ask that you send the request to me. My email address, kgracie@parallax.com. So I think we're just about got the classroom loaded. A few people may have fallen off. Wait one more minute.
Ken, I may have spilled the beans on myself because I put a post on after I'd done some pictures and shot a couple of videos telling teachers that why I have the best job in the business is because this is my professional development. But I'm afraid the comments from the English teachers were a little less than kind. And to be honest, my parents were married, okay, really.
They're envious because you're having fun. Okay, well, I think we've got enough people here. Good morning, everybody. Happy Friday. And isn't this great? It's June, it's summer. I think at one point we thought this would never actually happen, but what a relief. So now we can take a break. You guys all earned it, all of you educators. I know this was tough. I've heard from a lot of you. Today, Friday, okay, quickly we'll have some housekeeping, and then we'll go into some Q&A and some things that I observed through the week that I'll share back to you. Then we'll start some breakout rooms for those who want to get some one-on-one support. And then we have Andy, who will pick up about 20 after and go through the cybersecurity work he's been doing. And that will run probably till about 9:10 or so. And we'll conclude today by, say, 9:20 Pacific time. And at the end of this, we'll include our award ceremony. So just the housekeeping bit for the beginning. First off, I want to thank NYSERC again, the Cyber Innovation Center, for helping us out today. And thank you, Katie Henry Days, for your help on Wednesday. Today we have Callie as flight controller. She's going to keep the Zoom thing going for us. And I think for technical support, we also got Josh and probably a few others from NYSERC. I haven't quite seen, but the number of breakout rooms we have can be limited by the number of people we have to run them.
We're all lurking here, Ken.
Oh, you're back. Okay. I was wondering.
Yeah, we're just hanging out in the wings.
You're a hard one to miss. All right. First things first. I have with me Kate Hay here today, so I'm going to just pass this screen off to her, or maybe we can spotlight her video when she unmutes and talks. And Kate will be contacting you just to see how this is going and whether or not you're going to be using these in the fall. And we are not a pressured sales organization by any means, but we just need to know because this is the only marketing we do. We give out robots and we run classes for teachers. We don't go to expensive events and blow money. So we try to put it all where it really matters. So Kate, are you here? Checking in for Kate again. Kate, hey, do you copy? Okay, so when she shows up, we'll try it again to return to Kate. Okay, so still on the housekeeping side then. Just gonna share back a screen. Okay, a couple things to go through really quickly. The first was many of you were soldering various circuits together. We have this $5.79 circuit overlay board you can get where you can build circuits and then plug them onto the Cyberbot or really any Parallax robot. This was suggested by one of our teachers and we turned it into a product. So
and Ken, if I could, this is a really cool tool to have, because what you can do before you'd have the students actually build their circuit, but you can have some pre-made circuits that are the same kind of setup, and then that way the kids can look at yours somewhat for reference or whatever, but you also know that yours is not going to, something's going to be missing a part, a wire's going to be in a wrong area or whatever. It's not going to blow up in your face when you go to show it to the kids, and you can just swap those boards out. You unplug this one that you've made, put on your other one, pull off another one, and do another one. With NiceArc, we use these for show and tell at different conferences and stuff that we go to, because in a booth, curious fingers, what's this part do? And then they unplug it, and then it's a challenge to get stuff put back in place before someone else wants to come and look at it. So this kind of keeps everything nice and neat, locked in, and ensures that, like I said, nothing's going to blow up in your face when the kids are trying to build theirs.
Thanks, Tommy. Second thing, several of you, it's pretty clear now, have programmed a bunch of different microcontrollers and have experience with different things and really want to look forward and look ahead to what we're doing. So Parallax is having a live forum around a new product we just finished here in the last year after 14 years of R&D. It's the second version of our propeller chip, and it takes a long time for these things to really get ready for education. And the early adopters are way technical, but if you're interested in this kind of thing, we have a live forum that we're just starting up, and I will paste a link in the chat, and these are Zoom meetings you can register for. And I mean, some of the topics will be just absolutely way over our heads, but great learning experience. But I know several of you, this will fit nicely. Next, this was a support question. Okay, so it's about the whisker circuit again, and the teacher didn't understand, just couldn't get the head around why it is high when the whisker is not being pressed and why it is low when it is pressed. So I'm going to bring this little picture in front of you, and here's basically what's happening, and I'll ask one of you to explain it in other terms if my explanation doesn't make sense. When this whisker is not pressed, we have this 3.3 volt power, and that's just going through these two resistors because the current has nowhere to go. And so the I/O pin on the chip sees that as 3.3 volts, which is a high. Okay, however, that whisker is pressed. Now that current has a different path to take. It can either go through that whisker and through the posts on the board to the ground, which is connected to the posts and the whole chassis. With less resistance than it go through this 220 ohm resistor to the I/O pin. So in that case, it sees a low because the current's going straight to ground. I just kind of keep something like this handy, Stack Overflow article about 0 being off and 1 being on. Does someone else want to explain that a different way? Okay, Tommy, okay. Andy, you happy with that?
Yeah, I am. I think we might actually be able to add a little activity where we measure the voltage using the A to D inputs. And that would be kind of cool because you could actually have the terminal report what voltage it sees right at the intersection of the 220 and the 10K resistor there. And so that might end up helping clarify it for people in an activity way as well.
And you can also say it's like looking at a light switch. Is it on or is it off for students?
Andy,
Okay.
Can I ask a question?
Yes?
Or actually Ken, for that matter. So if you go back to the diagram you just had there, why do you have why is the order 10 kilo ohms, then the 220 versus 220, and if you exclude?
Andy, you take that.
Sure. The 10K resistor is called a pull-up resistor. And what it does is it's always connected to the I/O pin, P7 in this case. And that is what causes P7 to always detect a high signal when the switch is hanging open on the left. If you did not have that pull-up resistor there, what would happen actually is your 220 would just sort of be floating in the air, and it would essentially be an antenna. And so any electrical field, like if you've rubbed your feet on the carpet and you get somewhere near P7 with your hand, it might show you a 1. And then if you go away, it might show you a 0. There's no actual way to say, hey, you know, the whisker is not making contact. You just wouldn't know unless you had that large 10K pull-up resistor there. Now the 220 is actually often just replaced by a wire. We use this small 220 resistor because if you make a circuit mistake, it will protect the I/O pin from potentially conducting too much current and possibly damaging the microcontroller. Now, the reason that this 10K resistor is so large is because I think it's mainly a design habit. When you close the whisker, when you're on the right there and the whisker is closed, there's actually some current traveling from the 3.3 volt terminal through the 10K down to ground. And so when we design products that have contact switches in them, what we want to do is we don't want to use too much battery power when the switch is closed. So we use a large pull-up resistor, that one that's connected to 3.3 volts.
Okay, thank you.
If I can add,
Yep.
I'm sorry, if I can add, if we didn't have the 10K ohm resistor there, when your whisker was pressed, it would short circuit your power supply, and that doesn't let it last too long.
That also is true.
You'd be dumping the current into the chip.
Ken, I have a
ground.
question whether or not this is too simplistic. I'm trying to understand as an adult, but then be able to teach 8th graders.
Yeah.
So the diagram on the left, 3.3 is using a lot of current, and then the one on the right is not. Could it be said that it's using a lot as long as it's sort of acting like a sensor, always checking for feedback, and then once the whisker touches an object, then it doesn't have to check for feedback, it's already got it?
Well,
could it be explained that way?
Yeah, it can be. Yeah, so it's just continually monitoring the state or whether or not that switch is pressed, which is in technical terms the state of the I/O pin.
Yeah. Sorry.
Go ahead, Andy.
Wait. Oh, okay. So one of the 8th grade teachers that I've worked with a lot in a nearby school, she actually just recommends that students consider this to be a black box. She is doing it over a very short period of time, and so and her particular class is programming oriented, not circuit oriented, and so it's a point of interest, but she doesn't really try to go too in depth on how the circuit works. Incidentally, the circuit on the right does not conduct a lot of current. The 10 kilo ohm resistor is a largish resistor, and so what that does is it has a large amount of resistance against current passing through it. So when the whisker is closed, when the circuit is closed, like on the right, there's only a small amount of current that passes through. And if we used a smaller resistor there would be a lot of current, there would be more current that passes through, and that's the thing that would run down batteries more quickly.
Thank you.
Good. All right. So next up, I sent you all a very clunky program thinking somebody would comment and say, that code is no good, Ken, but nobody said anything. I believe I included this program in a zip. It's the Imagine Dragons Believer song. And this was given to me by a teacher. It was written this way. And you see a lot of repetition here in certain commands. And so I wanted to point out there's an easier way to do this stuff. And what I'm talking about here is memory usage in the microbit ultimately, because several of you ran out of memory. And there are a number of ways we can work around this, but you can't increase the memory at this moment on the microbit, but there are things you can do. The first off is you can write more concise code. So it's clear and understandable that many of you who teach computer science have used Python on computers where you're allowed lots of very verbose code. And on microcontrollers, it's not really that way. And sometimes as you condense your code, it looks less elegant and less proper, but it works better. I mean, if you just want to play Twinkle, Twinkle, Little Star, you know, maybe this is fine to write it this way, but you can also tighten it up, and I'll show you an example of that. So here's the rewritten song using lists, where you put the notes in one list and the duration in another, and then we made a loop which steps through those 35 notes and then plays them. So that tightened up that program significantly. This was one I received from one of you 2 days ago. And this one had another more advanced Python concept, dictionaries, which Andy is using in the cybersecurity part, using these key value pairs. But to write a song this way is difficult because although you could define every note and the length, you have to first look up what the note is and then what the length is and then get the number. So Andy and I spent a few minutes trying to rewrite this code, and it just became a little more complicated. So we sort of settled on making a list. I mean, if we just want to play Twinkle, Twinkle, Little Star, you know, here's a good way to do it with low memory. And I think this code is from Tom, but he got a nice project working out of it. So again, it's not like really useful, reusable code like this. The goal of this would have been to find every note and length and then just call them. But we got the job done. So other things you could do. There's an article that I'll post right now in the chat about microbit and memory, which you can read. So there it is. And here it is on my screen. So they talk about the following tools to increase your memory. First off is shrinking variable names, deleting comments, using less white space, etc. So here's a technical article. You can read it on your own leisure. And then finally, there is a solution Parallax is working on with NiceCirc, where instead of including the entire Cyberbot library, you can just include the functions you need. And then there's a little more terse syntax you would use to call those functions. And we found that to be the greatest savings. But in general, it seems to me like depending on what you include, you can get 80 to 100 lines of code, depending on which modules are included. So Andy and I have kind of summarized it as several systems working together, 2, maybe 3, depending on how tight you can write things. Okay, just moving on here to the Mu editor. So let's see if we can get this to work. Several of you have been asking about this, and Katie pointed out there are hundreds of editors you could use with the microbit, especially I think with the block programming. But this is probably the most popular one. This resides on your computer, and I think I like it because it has local file save and load buttons that I'm kind of used to up here. And you can drop your code on it onto the microbit, the modules, using the files button. So you just have to put the Cyberbot library in the Mu code folder, and then it appears here. Then you can drag it over. So close that window. But what I really like about this particular editor is it has this graphing capability. So I'm just going to download this code to the microbit and then set up the plotter. And this is the 3-axis accelerometer. And I'll just kind of move this thing around here, let my gripper wrestle with the microbit for a minute. So yeah, and my screen's already kind of froze, probably because I'm dumping data too fast in here. But there, it came back. So if I did this 10 times a second, it would probably just work a little bit better. But yeah, you get the idea. So you could just use a print command, and then the plotter will intercept those values and make an axis for you and everything. Data flood detected. Oh my gosh, stand back. Okay, so we'll just turn all this stuff off.
Data flood. Lifeguards are on duty.
That's right. Okay, so briefly now, we just want to talk about, see that it went well with everybody for the infrared circuit and then the light following circuit. And for those who have questions, we can start up breakout rooms and answer any level of question here. So just any general comments from people on how that went.
One comment was when I cut and pasted from the tutorial, several of the programs did not have a carriage return line feed after the last line of text. And therefore, when I tried to flash the microbot or the Cyberbot, it said, oops, you got a problem there. And then I had to add a carriage return line feed, and it worked perfectly. It was a quote underscore main underscore error of some sort.
So you got hit with the syntax there.
Right,
Andy,
you might want to add another line to those.
Okay. Do you remember which code it was? Just let us know. When you
all of them.
Oh, all of them. Okay. Maybe making
they were the cyber ones.
Okay, we'll look at that. First time I've heard that, and I have experienced it. But just general note on that. When you encounter anything like this, email us right away, because that means everybody else is falling into the same trap.
Apologies.
Okay, did we get some success on the light follower circuits? Maybe give us like, okay, see some thumbs up. Oh, you're all trained now to use the reactions button without even being asked. I wish I had some treats handy for you. Okay, well, how about this infrared circuit that I'm showing? Anyone get this to work?
Hey, Ken, this is Jay.
Hey, Jay, how's it going?
It's going pretty well. No, the infrared was actually cool. I actually showed my wife, and she was like, oh, that's neat. We can get, that can be our new pet. So she, yeah, I don't know. Well, but yeah, she really liked it. It worked fairly well.
You have an understanding wife. Congrats.
She has a great husband.
Well,
if you're going to use it as your pet, you should get some rechargeable batteries, though.
Well, this is a challenging circuit, and I'll show you later this morning how it was adapted for more advanced uses even. But it's impressive you got here after a couple hours of this distance learning. So good job.
And
now,
I have a question, General. Oh, by the way, I don't know who said that, but I had the same comment from my wife. Can we turn it in, dress him up and turn it into a little pet? Because I wanted the Sony Aibo, that robot dog. But she said we could turn this one into a dog. but anyways, the question was, if you had this IR circuit and you still had the whiskers on and they're in front, would the whiskers have an effect?
Well, only if the whiskers are in the way of the IR, but it'll become more of a wiring challenge. And you could use them together. You just have to look out for the physical interferences and make sure you've got enough breadboard space to build them.
Yeah, the main thing is when you press the whiskers, you don't want that metal, the metal whisker to come across the leads for the infrared LED or the infrared receiver that you can see in the picture right now. So you need to move them back a little bit, and yeah, just be really careful about that, or put some electrical tape around your whisker anywhere where it might make contact with other circuits on your board when you press it.
Okay.
Thanks, Andy. Okay, so at this point, we'll open some breakout rooms. Callie will get a few together, and we can get one-on-one help for any kind of question you've encountered so far. Because I've got some.
One.
Yep.
I'm sorry, I'm not spoken. I noticed that with the darker colors, it didn't really register as much.
Yeah, so that's exactly right. The reflection distance will decrease, or it may not work at all, because dark colors, black colors absorb infrared, and it will not bounce back to that receiver. So like we have black, for some reason in our office, we have black baseboards. You think a robot company would not have put black baseboards in their office.
Yeah, a funny story. We also have an ultrasonic sensor. So that sends out a burst of sound, and it's kind of nice because you can put the ultrasonic sensor on the robot and it'll use the burst of sound to detect some things, and then the whiskers will detect other things. Ken contacted me one day and said, hey, you know, my students brought a teddy bear and the ultrasonic sensor just could not see it. Does anybody want to guess why? Well, the answer is that the ultrasonic sound just got muffled by the teddy bear and didn't bounce back, much like a black baseboard will absorb infrared light instead of reflect it so that the robot can receive it. And so the idea is, you know, use more than one sensor system to detect something on your robot. And that is a very common industry thing.
So the typical sensors we support would be the ping sensor, which is ultrasonic. Someone's got to mute there. Okay, thanks. And then there's a ping with laser that works well in all conditions. And then there is the infrared and then the whiskers. So they all have their benefits. Okay, so let's open those breakout rooms. And so if you need help, you could just put in the chat that you need to go to a breakout room, and then Callie will create a breakout room and then drop you in there. And then you can come back to the fun and then see the recording afterwards of anything you miss. So at this point, I want to pass this over to Andy, and we can keep using the chat for other stuff while he gets going. So Andy.
Oh, I'm up already.
All you, yep.
All right. Hi, my name is Andy. Ken asked me to show you some of the things I've been working on with cybersecurity. We went to a conference back in December and saw some really interesting and exciting examples. We did a class like this one, except for in person, with this robot, and came to find out that there was considerable potential. Say, does anybody know, can you see my screen right now, where suddenly I got a notification about a chat in the Zoom meeting? Do you see that?
No, we're actually looking at your camera, Andy.
We see you.
Oh, okay. Callie, could you put the focus on my screen?
Let me attempt to do that.
Okay. Or wait, I can share my screen.
Yeah, do that, and then they'll.
Whoopsie.
There you are.
Sorry about that. Okay, so well, who knows? Maybe the chats won't come through while I'm sharing my screen. All right, so Ken and I went to a conference. We saw lots of, we presented some neat stuff, and then saw lots of neat stuff on cybersecurity, and came back and thought, wow, there was this neat presentation where they used one of our robots and actually put it on a network, and did a cybersecurity camp. And we evaluated that and found that the level of challenge for a certain number of teachers was going to be really high in terms of getting their network set up to repeat that. And so we looked back at the Cyberbot and realized, well, hey, this thing has a built-in radio, and we can actually create a network of radios with it. And so couple things before we get started talking about that. First of all, the slideshow has presenter notes, and for those of you who have the slideshow open, what I did in the cybersecurity stuff is I put links in the presenter notes. So in this first slide here, it takes you to the cybersecurity tutorials, and so here they are. Or it says it's taking you to the cybersecurity tutorials, but in reality, what it's taking you to is the Cyberbot tutorials, which contain a number of cybersecurity tutorials. For example, here is cybersecurity radio data that you hopefully had a chance to look at, and then cybersecurity radio basics. And there's a number of other ones that are on their way here. But in general, this is where all of the student material for the Cyberbot is going to live. And so this is an important link that you have hopefully been to, but if not, I think I'll post it into the chat. Where is my chat? When I went to screen share, I lost my chat. Here we go. Paste. So that is going to be your main link. Now, from here, you can go sequentially. For example, here's your microbit setup, programming, and then further on, we get to building the Cyberbot and doing the various activities that you're now very familiar with. So this page is your main page for resources that the student is working with. It's kind of like your student textbook. Then just remember, in the educators section, you can go to Cyberbot resources. And once you're here, that's where you've got stuff like, this is where the curriculum part comes in. And so, for example, there's slides, here's a link to the slides that Ken and I are working from. The standards matrix for standards alignment, if you need to justify the purchase. And then in here is a locked up area where once you have your login for this, you can go in and get question and solution sets to set up homework labs and other things on top of as the students go through the material. How's that? Is there any questions about that in terms of what Parallax offers in support of the Cyberbot? I'll take silence as assent. Now, the next thing is, hopefully everybody remembers that there's also nycirc.org. Man, there we go. Sorry about that. Okay, and when you go to nycirc.org, this is a place where you can find a second set of curriculum. For some of the Cyberbot stuff, you can just go to curricula and then curricula access and either sign in or request access. The difference between the NYCIRC material and Parallax material has a little bit to do with emphasis. Parallax is kind of in the inventing realm, you know, teaching how to invent. That's that's one of the things that's really important to our company culture. And NYCIRC is more interested in cybersecurity and workforce development. So what's nice is you have two sets of free curricula for the Cyberbot, and you can take resources and mix and match them. And I wanted to just make sure, I know you've probably seen all these before, but I wanted to repeat them because they are very important places that you can get material for your classes. The second thing I wanted to show you before getting started is, okay, so here I am. I've got some code here, and it's running, right? You can see some code running on my microbit. It's saying hello, and then it's gonna display the heart. Now, so great, my microbit's running. And now I'm going to go to the Parallax tutorials and do this little program here. And as a teacher, I might not have time to hand enter it, even though I tell my students to hand enter it so that they can kind of absorb the coding material better. Can everybody see my screen okay? Okay, thank you. Excellent. All right, so I copied and pasted some code in, and then I'll go ahead and load it into the microbit. And do you see now that, oh darn, I'm stuck. It's displaying an error message. Oh geez, it's been a few months since I used the Cyberbot in my class. What's going on? Anybody want to give me the answer to the question? What did I do wrong here?
There's no carriage return after line 10.
Well, for me, that is, I do not think that's the fact, but we'll check that in a minute. Any other guesses as to how I messed up? I know there are some chats coming through, but I can't see them. Did anybody announce my mistake in the chats?
Some of the ideas you've got coming in, Andy. Go ahead.
Your import. Which board are you connected to there? It looks like you're connected to the microbit, not to the Cyberbot board.
Well, that is a good point. So let's fix that problem. Okay, so I just went ahead and disconnected. I just went ahead and disconnected my microbit, and now here I am with my Cyberbot board.
Is none not defined?
None is defined.
Okay.
But when I run the program, and I have the 3 position switch in 1, so it's ready to go. But look at that; it's still showing me an error. And I did hear somebody say what the problem was. The problem was that I forgot to import
Include the Cyberbot library.
Yeah, exactly. So now I'm going to go and add my file here, and then everything will hopefully work fine. Why am I not in downloads? Okay, so Cyberbot MicroPython, and there's Cyberbot. And so now we're okay. And so we'll try downloading again. I'll put it in position 2. And look at that, off we go, almost off the desk. All right, so, so now that that's working, how might we prevent that from happening next time? Well, it's pretty easy. Basically, at this point, I could actually take this file and say, well, let's just have a blank Cyberbot file. And maybe in that blank Cyberbot file, I want to make the speaker beep every time. Is it 22 for the speakers? Something like that. And then a quick little maybe move forward for just 1 second and maybe a little slower so that we don't go off the table. And then sure, stop. Okay, so now this is a file that every time I use the Cyberbot, I just want to be able to have that file. So I'll download that file. And here's the trick. Okay, so now I've downloaded that file and it is in my downloads. Microbitprogram.hex, because that's the name I gave it. I should have given it the name like something like underscore blank or Cyberbot blank. Okay, now I'm gonna save that again. Download project hex. Okay, so here is blank Cyberbot hex. I know that might be a little bit difficult to see, but it's in my download. It's a file, starts with underscore, so if I sort by name, it'll come up on the top. So next time I open my microbit editor, okay, so here we are back to the beginning again, okay, and if we look inside OG, I don't have the Cyberbot module. So we don't, the thing I'm trying to get at here is we don't want to have to do that every time. So you can basically have this blank Cyberbot hex file, and you can drag that from whatever folder you're keeping it in. It's in my downloads, but you can put it anywhere. And when you download it, you get not only the code, but you also get, can everybody see that okay, the Cyberbot module? Whoopsie.
The module travels with the hex file.
Yeah, so that's an important thing. So I keep that Cyberbot hex or Cyberbot blank file around, because anytime I want to copy and paste some code from the website, this saves me the steps of adding the module or forgetting that I added the module. Does that make sense? Okay, now the last thing then is here we are back at the website. So I will paste in my test code that is forward 3 seconds. The important thing to have your students do is remind them that they need to save their file. So I take that forward 3 seconds and I put it in the script name. See how the script name is now forward 3 seconds? That way, when you download the project hex, I'll switch over to my downloads. And here is forward 3 seconds. Let's see if I can zoom in on that so you can see it. There we are. Okay, so see in my downloads, now I have forward 3 seconds and Cyberbot blank. And so the important thing is when you're doing, that's the equivalent of file save as, is to basically change the script name here and then go to the down, or I don't know why I'm hitting the wrong thing here. There we are. So basically the download project hex is your friend for saving your files and giving them meaningful names that are in your file system. Are we good with that? Okay, excellent. So next up is talking about the cybersecurity material.
Just before you do that, in the NYSERC setup, it looked like it was only for K through 12. Does that mean that there's a separate access for college or not?
Can I have somebody for NYSERC jump in and answer the availability and usage scenarios?
I can answer that. We have funding from a federal grant that mandates that our content be made available to K-12 educators in the United States. There are some exceptions for college professors who are working with high school students, for example, in a camp setting or a dual enrollment kind of thing. But right now, that is a limiting factor.
Okay, so I would have to just indicate that I will also be doing K through 12 STEM stuff.
That's correct. So if you sign up for access, you're probably going to get a response back from Joy Beth asking what exactly your plans are with the curriculum. And so if you can explain what you're doing with K-12, then we'll be happy to give you access.
Thank you.
Yeah, another university setting is if you're developing additional curriculum material, I would imagine that they'd also want to give you access in that condition. Okay, well, thank you, Callie. All right, so cybersecurity curriculum, here is the initial offering that I'm hoping to have all nice and posted in just a couple more, within just a couple more weeks. I'll show you in a second what's currently available and what's still under development. But the idea here is that there are some coding basics. So computer microbit talk, for example, is something where you're using the terminal to communicate back and forth with your microbit. And then there's some other things like dictionary primer and exception handling. Although we're doing it in Python, these are staples of web development. Because if you've ever had a web page freeze, in many cases it's because it didn't handle some unexpected condition. So that's where exception handling comes in. Dictionary primer, every time you do a web search, for example, it sends something that's akin to a Python dictionary. String manipulation is also important and also related to, a number of real-world applications and especially the web development kind of thing, because all kinds of messages are passed back and forth between browsers and servers. So these are tutorials that are essentially the basics that you'll need to do cybersecurity, but also the basics that students will need that pertain to a number of different professions that they could go into in the cybersecurity world or the cyber world in general. Radio basics and radio data and are also kind of like exchanging messages over the internet, but we're using the built-in radios in the microbit. Then we go on to some things that will use that can be hackable. So controlling a robot from a keyboard over the radio. Well, if you're sending messages through one microbit from your keyboard to a remote robot, other students could hack in and prevent you from winning the race. And so, this is essentially a place where open communication starts, and you get to see the impact of what hacking can do to your robot performance. Then we go through a series of learning experiences where there are various kinds of attacks that are made as you're trying to control your robot, and various ways of defending against those attacks. We also have some cool projects like the Tilt Radio Control, which is just about to get posted, and the Hackers versus Defenders, which is kind of a contest environment. Now, what's currently up on that site I showed you is everything that's in green here. And if you go to the speaker notes, there's a legend for this, but basically everything that's in green is already up on the same learn.parallax.com site that you've been going to for the other material you've been working from. The blue, strings primer and radio tilt control, are in their second draft and going through editing and posting to get them up on the web. And then I'm currently in the middle of basic encryption, doing the second draft. We had a think tank with NYSERC in January where we cranked out all the first drafts and decided what material to offer, and this is what we came up with. Any questions before I move on? All righty. Please feel free to...
Just quick one, Andy.
There we go.
Sorry. The other ones, the simple attacks, the DNS, the denial of service, DDoS attacks,
yeah,
brute force. What's the estimated time for those?
Oh, like I would say that everything should be up in early July. I'm trying to get out of those within 2 weeks. And so, and then there'll be a little bit of time for final editing and posting.
I want to ask him that question. Andy's boss is on the call here.
Yeah.
Put him on the spot.
I work for Andy anyway. It'll be totally ready by fall.
Yeah, they're on their way. I'm basically in my final sprint, and this is something that Ken has seen me go through over and over again, where I'm kind of slow on the earlier material, and then all of a sudden there's this vast amount of stuff that appears. So,
Andy.
Yes.
Do you cover things like Caesar ciphers?
You know, I'm glad you asked that. Yes, I'm going to show you Caesar ciphers shortly.
Hey, Andy.
Yes.
I have a question for you.
Okay.
And I put this in the comments. This is great, and we do teach a lot of this in our AP Computer Science Principles class.
Uh-huh.
But what I have trouble finding are videos that hook the kids to help them grasp why we're teaching them this. Do you guys, or does anybody know a good set of videos that can be used just to capture those kids' attention so they understand the why behind why we're teaching them this?
So off the top of my head, I don't have a video link, but since the question is out there, I'm confident that a number of teachers are going to be posting links into the chat. But what I can say is that having the robot and getting to play with it is a motivating factor. Additionally, seeing the impact of these attacks on the robot is a nice parallel to essentially the effect of performance on your computer when like a denial of service attack is is in progress and you can't get.
And Andy, there's so much information in here. Are we going to have access to this Google document or presentation?
Did Andy freeze up on us?
Yeah, you already do have access to it, and I'll paste the link right now in the chat, and it's through the Educator Resource tab as well.
Thank you.
You're welcome.
I have a quick question. I know in Dallas they have a hackathon. Do you guys perceive or foresee you guys maybe possibly doing that? That may be a hook. I know our girls like to compete, and I'm just kind of thinking about that myself as far as in the classroom. That may be something that can, you know, have a white hat versus black hat kind of deal.
I'll answer that. Not at the moment, but NYSERC is more likely to run such competitions. Like they have the Regional Autonomous Robot Competition, and they're big in Texas, Louisiana, Arkansas. So you might see something from them, but nothing from us yet. We'd love to do that, though. Great question, Jay.
Yeah, and Jay, on the different competitions and stuff that we've got going on, if you, again, follow NYSERC social media, you'll see different events that are coming around. As soon as the whole COVID, everybody, you know, was thrust to work at home, we started doing some monthly capture the flag competitions that were free. Some geared for families to just sit down. It's kind of like, oh, what are we going to do now with the kids? And so we had stuff like that was filling in that didn't require any sort of technology other than just you and the computer. And then the RARC, that's the Regional Autonomous Robotics Competition that Ken just mentioned. That's a robotics competition that we organize and push out. That way you can find information of that on our website. Different opportunities, but nothing geared with the Cyberbot yet. So, great idea. We love those kind of ideas and feedback from teachers. Just keep feeding us ideas like that and we can put something together.
Okay, and I think Andy may have dropped out of the Zoom meeting, so it might take him just a minute to get back in here. He may be having some internet trouble. So while he does that, usually he returns. Kate, if you're here, can I just do a quick introduction with you?
Yeah, I am here.
Okay, there you go.
Yeah, I've been quiet. Hey, Tommy. So nice to see everyone. Awesome. My name is Kate Hay. I'm with Parallax, and I will be doing the follow-up calls after you attend all these lessons. So I've been calling educators all across the country, just asking them how their experience was with our distance learning courses. And then also, first question, I'm just gonna run down really quick. First question I ask is feedback, any suggestions to make this course better and help you with the learning of the Cyberbot, all the other robots. Second, do you need any additional support or resources at the time that I'm gonna be calling in a couple weeks? And actually maybe a week. And then last but not least, we're kind of, asking how you will be integrating the Cyberbot into your curriculum. Right now, we know that school is up in the air. We don't know how the structure is going to be, so it's been a really hard question. So I've kind of turned my question is, in your dream world, in the best case scenario of a perfect school year, how you'll be implementing it in your courses, what type of courses you teach, and just the details like that. So 3 simple questions. Look forward to speaking to everybody. This is an awesome course and an awesome product. So we're excited to have you guys here. And also just if there's the people from Everett High School, I actually talked to Neil today just before this course, and he said that he actually shared the videos of his experience with the Cyberbot distance learning, and there's other people on here and you guys decided to join us. So that was really cool to hear that suggestions and more people recommending our products. So that's all I've got, Ken.
Thank you, Kate, and have a great day.
Thank you so much. You too. Bye-bye.
Yeah, so when Kate shows up, if you could just answer her questions, and then that would be awesome information for us. So we'll give Andy another minute here and get set up to take over in case he doesn't come back.
If I could just jump on for a quick second while we wait and say, I love the question about the videos and the why for the students. I copied all the links for everyone's resources they've been dropping in the chat so that I can share those with others as well. And I know we all have a personal story about how we got into the work that we do, but I just want to quickly share that I could have been a student in any one of your classes and would have loved to have been, but wasn't because I didn't know about it. This topic existed when I was in middle school. I'm probably a lot older than you think I am. Most people are off by about 20 years for my age. But it's really nice to just see the questions that you're asking. I was very big fan of Nancy Drew and Spy Girl mysteries. And every time I think of cybersecurity, I think of Spy Girl stuff. And I love talking to middle school girls about cybersecurity because when you present it as Spy Girl, they get real excited. Of course, there's all different kinds of spies, but Spy Girl resonates with us with a certain group. So thank you again for being here today. This is very lovely.
Thanks for sharing that, Katie. So, okay, where was Andy going? I'm going to flip back into the slideshow here. And I wasn't totally prepared to take over, but this is content you can look at on your own. I'm going to hit some of the high points for you. First off, we found this to be a big issue when doing the cybersecurity tutorials, and it is Chrome. Chrome apparently in recent months and years has become more of a resource hog than it was when it first came out. So when you are hooking up a Cyberbot and using what's called REPL, which is the terminal program, and hey, Tommy, maybe what you can do is get one of these chat programs going, or the one that does the key shift, so we could demonstrate it. I think slide 130, it's linked in the bottom. We can share your screen. Okay, so you have to maximize Chrome, your computer's performance, and run off power supply, and then close out unused tabs. And this is when you're using the Python editor terminal, okay? So there are ways around this, and those ways include using Muse terminal, which runs locally and will work more reliably, using something called Parallax serial terminal, which is a PC-based program where you can transmit and receive data. So once you put the code into the microbit, then it's just sending data to and from the computer. You can use pretty much any terminal program. We try to do it in Chrome because you're already there, but we found with some computers, it just doesn't work that well. So that's an FYI. As we get into this, students have to learn about this, which is the ASCII chart. I'll make it a little bit bigger. Every letter and number on your keyboard has a numerical equivalent, okay? So, and what this allows us to do when we understand these numbers is we start to learn about strings and decimals, and then how to turn one letter into something else. And here's a good example. And Tommy, if you have this code up and running, maybe we could show it.
I don't. I was completely unprepared.
Okay. All right. So here's basically the way the code works. And this is actually already in a tutorial, but you're given a prompt in REPL. So you may remember we call it the terminal. And that's the way of seeing errors that show up from the microbit. But there's another button there called serial terminal, where data can come and go from your microbit. So running this program, it prompts you to enter a value, and then it displays the ASCII equivalent of that character or number you enter. So ASCII's been around for a long time, and some of you could talk probably for hours about it. One of you even participated, I think, in the creation of ASCII. All right, so this would be when you send data openly between microbits using the radio, which is one of the huge strengths of the microbit. And by the way, I'm so curious, nobody has used the accelerometer as a bump sensor yet on the robot. I really want to see that. Come on, the challenge is placed. Now someone show us. So the radio is a tremendous benefit to this because it does not require external hardware. Once you're sending open characters and controlling a robot, you can control the whole classroom of robots, shown as in here, in this video. So we just filmed this about a week ago. And this is the project that is actually posted, I believe, on the tutorials now. So here's 20 robots under control.
And obviously the video is a lot smoother when you're playing it on your computer.
Yeah, and I'll
a little
just
jerky on this end.
Drop that into the chat so you guys can go watch it on your own, because it's definitely fun. So that video is now linked into the chat. Okay, so the beginning would be driving everybody's robot, and then the next thing you would do would be add a shift, a key shift, so that when you send one character, it's actually something else on the other end. For example, if you type in an A, that's ASCII 65. But if we shift it 10 to the right, like you see in this line of code, now it's something else. Now it's a K, all right? So you can lock this down. You start by doing a key shift, and then you can actually use channel IDs in the radio. So you have several layers here of security that you could add so that you cannot control everybody's robot, or they can work in pairs. There's a very fun example that will cause absolute chaos in your class. And you might just have to turn your head when you do this thing. But everybody loads the same code up. It's wide open communication, and they all have a chat window going. It's basically texting. And anything you send shows up across every computer in the class. And this this is not so fun with distance learning, obviously, because we don't have Wi-Fi connectivity. Someone just pointed that out. How are we going to do this? Well, there was no COVID when we started these projects, but at least the microbits are cheap enough. You can get 2 and plug them into 2 ports. So yeah, this is when the students start entering things, and then, well, you know what happens. Here's a video example of it in use. And again, sorry if this isn't very good over Zoom. So we're going to type in hello, got received, and then anybody here with a microbit can just start typing in anything. All your bases are ours.
It doesn't just have to be between 2 microbits. You can have multiple microbits that are on the same kind of chat channel with this kind of setup.
And then this will just scroll down so fast when everybody discovers it.
So it's a lot of, you know, that might be a good reason for why, you know, that might be a good use case that you want to have multiple people responding to the communication. You send, when your city or emergency management service sends out some kind of alert, you know, severe thunderstorm warning or tornado warning or whatever, they want that message going out to multiple people. But when you're sending a you know, a private message or some kind of financial transaction, you probably don't want a lot of people getting all the information. So that's where encryption would come into play. So the use case really kind of determines how things are going to be structured in this kind of chat setup. So you've got messages being sent from one to the other, but as Ken showed earlier, you've got the shift cipher that you can shift those letters in and provide some small layer of encryption on here. Shift ciphers are not good, solid encryption, but it's a start, and it's something that just for the educational value, it's a good target to have.
Yeah, for a network class, and I have not been in such a class, but you're often teaching how to use and configure and discussing software and how the layers work. So here it is at a super low level, and hopefully the idea we're trying to get across here is the robot is the video. You know, it's the real deal, and this is the fun. And the tutorial should step you through this in a very reliable manner. Here's a picture of how Andy's using a dictionary with key pair values. And so now we're using the dictionary command to transmit pairs of values. So this is Python coding as well as security, as well as RF communication. It fits in a bunch of places.
So Ken, I had a question regarding the address parameter for the radio.
Mm-hmm.
It appears to be a 32-bit. I mean, it's currently set to TBIR, TBIR, as a default for all of the microbit. But do we have the full range of addresses in that?
So my experimentation understanding with Andy, who spent the most time on it, is you have about 80 channel IDs. And
right, that's the channel.
That's the channel.
There's the address parameter. There's the address parameter.
Oh, he's back. Okay.
Yeah, I think there might be an AT&T truck in the neighborhood. The internet was gone. So yeah, I looked at my computer and the resources were fine, and so yeah, but the internet finally reappeared. So Bob, you're asking about the 32-bit address space, and the answer is yes, you can make it uber secure that way, but it's better from a teaching standpoint to have students working on in an open environment initially, because that is really a better example of how you know, things are essentially vulnerable, but they can be protected.
Yeah, start off with a broadcast address and broadcast messages, and then go to private channels and private addresses, stimulating the MAC addresses.
Well, Andy, now that you're back, you can take over. This is where we were. We were just speaking in general terms, and I showed the video of all robots under control and basic key shift.
Yes, yes. So
do you want screen control again?
Sure, I'll take it.
Okay, back at you.
Although
You're still booting up.
Well, no, because my computer did not have trouble.
Didn't fail, just the internet.
Yeah, that's what it looks like.
And if there are any questions so far while Andy gets reoriented?
Yeah, sadly, my equilibrium is somewhat gone here.
That's okay.
But yeah, I'll see if I can recover here. I guess the main thing is I need some guidance because it's already 9:05. So I didn't see what you did cover aside from that I do see that you looked at 2 microbits chatting.
Yeah, so we did chat, and then we talked about, we showed chatting with 1 key shift, and we were just about here on error handling.
Right, and so I wanted to go back, this computer microbit talk slide right here. This is, we talked about having teachers try out
Share
something
your screen,
where,
Andy.
Oh, sorry. Okay, let's see, share screen.
Hey, that's totally okay. There are 50 teachers here who are dealing with the same exact thing times 5 times a week and vaporizing students.
Yeah, boy, I'll tell you, I did quite a number of things to make sure today went okay, but
that's why I have 2 different internet connections at home.
Yeah, well, don't tempt me. All right, so getting back to the screen where the presentation is, here we are. So one thing we could try is simply using the terminal with our microbit. We talked about that as being something that everybody should definitely try. How many of you have already tried communicating back and forth with your microbit over the terminal? So I see 2 professors raising their hands. Anybody else? Can somebody give me an idea of whether that's like something we should skip or something we should do? I see only a few thumbs up. Okay, so
I really think you should do it. There's some really simple. It's actually really simple when you actually try to do it.
Yeah, I think you should demonstrate it as well.
So what I'll do is I'll chat you a page here. I want to point out that every time you see a badge on a slide, you see this badge in the upper right, that is a live link to the activity that's being referenced here. And so you can follow that. And here we go. And then in the slide notes, which I'm not going to go back to, so it basically takes you to the beginning, but the slide notes is highlighting the very last activity in Computer Microbit Talk. And I thought it would be a fun one to try. And so I'll go ahead and chat you the, let's see here. I need to, here we go. Chat. Okay, so I'm pasting in a link to that. So you guys can all go to the page that I just pulled up. Did everybody get that chat?
Got it.
Okay, so I'm going to simply take this text right here and paste it over my oopsie, got to connect first and then load it. And then after loading it, you can go to the, I should make this a little wider so it looks more like your screen. Go to the Open Serial button. And see how it displays enter seconds to count down? So I'll count down for 5 seconds. And so that's something that I typed. So I clicked this and then typed it, and then enter message after countdown. And so after I hit enter, after typing Happy New Year, there we go. So that is an example of both typing messages to and receiving messages from your microbit. And it's the tail end of the terminal talk set of tutorials. So I highly recommend that you try these out because it's essentially, the most important entryway skill into the cybersecurity, where especially for those of you who have done router configurations, boy, you use a lot of terminal. You use the terminal quite a bit. Any questions before I move on? Let's see here. All right.
Andy, we spoke briefly what you just demonstrated using the terminal and how it causes trouble. And maybe, Tommy, you can paste in links for the code with mu and then also the Parallax serial terminal, which are a couple of options in case you have trouble doing this in Chrome.
Those were just a link to access
code with mu as the alternative editor, and then also Parallax serial terminal. I'll go get the serial terminal link.
Okay.
Okay, so while you're getting the serial terminal link, I'll go ahead and show you the serial terminal. Let's see here. The Parallax serial terminal is here. So this is what the Parallax serial terminal looks like. And essentially, you want to disconnect the online editor before connecting with the Parallax serial terminal. Here is the online editor. So I'm going to disconnect here. And then going over to the Parallax serial terminal, it looks like I have 2 microbits connected. Let's see if this one is the one that I want to use. I'm pressing the reset button on the microbit. And no messages there, so let's try the other one. Okay, so here is countdown. I'm going to connect and download, and then disconnect. Then I think I'll unplug one of the microbits because I have more than one connected. Ah, here we go. See now where it says enter seconds to count down? So in a terminal application like this, you would enter the number of seconds upstairs. So this is where I'd enter 5, and then see down below it shows you the 5, and then enter message after countdown, and we'll do liftoff this time. And when I hit enter, we get the same behavior essentially that you see in the microbit editor, the microbit editor's terminal. Okay, so Ken, what else would you like me to cover? I can continue with the slides, or
I think you were going to ask them some questions about their preference about how we present some of the material.
Okay, so
if that's appropriate.
Sure. I think to do that, I'd like to take a look at a draft of the beginning encryption material. And that is in the slideshow notes a little bit earlier on here. So in the slide that shows what, the level of progress, I put links to the drafts. And so the encryption intro link is right here, and I'm just going to go ahead and open it. And so one of the questions I have for you is how your students respond best to tutorial information. We have experimented in Parallax with a number of different styles of presenting to students via web pages. And so there's emphasis on certain things by certain teachers. Like some teachers believe that learning by doing is the most important thing, and they feel that blasting off straight into it and then having questions later is the right way to go. Other teachers have said, wait a second, you know, I don't even know what my students don't even know what they're doing before they're getting started. And so I think the biggest question I have, so this is an explanation of some really cool code that Tommy put in the intro to encryption tutorial first draft. And so what I did was I illustrated it here. And what this is an approach of trying to say up front, hey, this is what it's about. We're going to encrypt the information, you know, look at that H. Well, if you take that H and then look at the alphabet and you skip over 5, the H can become an M. And if you take that E in hello, our plain text, and those are cybersecurity terms for it, and start at the E and jump over by 5, you get to J, and then there is your ciphertext, your encrypted version of hello. And so this is an example of explaining a little bit up front about how a student, you know, what a student should expect before then jumping into the program. And actually, currently I have, you know, the concepts of encryption and decryption discussed up front. And once they've discussed it, now it's time to actually write a program. Another thing that we've done is put that kind of discussion afterwards and how it works. And what I want to know from you teachers, it's very important to us to get this right, to have it so that your students can best work with the material. And so my question for you is, or my first question for you rather, is up front or after they've tried it? And I guess I'll try to open up.
I think they need to try it so they can make mistakes.
Okay. So we have one vote for try it. I'm really interested in discussion here because it's let's see, I'm looking at the chats now.
Yeah, I like doing a demo of something to show them what it's going to look like.
Okay.
And then have them try to do it.
So from that standpoint, what we really would want then is something that shows them what to expect up front, like a little animated GIF of what's going on, and then they do it, and then afterwards is when we go into learning about it. Is that what I'm?
Yeah. Well, I actually do a live demo. I'll do a live demo up front. I already have it prepared. Do a live demo up front. Then they'll go off and try to do it. And then we'll go into why did this even work?
Mm-hmm, mm-hmm.
Or why didn't it work?
Yes, and I see a comment here about teaching philosophy, discovery learning, and et cetera. Demo followed by troubleshooting, try it first.
Andy?
Yes?
I think one of the things that, I mean, I kind of agree with everybody too, let them try it. I think that's just where we're all at, or the world that we live in, letting them try to figure out their mistakes and then explain it. But the thing, again, I think we're missing is the why. Why do kids need to know what we're trying to teach them? How is it applicable in the real world to be able to give some kind of background connection?
Okay.
Yeah, okay, you always want to relate it. You want to relate it to the real things. And like for young people, it's like, do you want your parents to see your chat messages?
Yeah, although that would be a little bit touchy to put in our instructional material. But okay, so what I'm taking away from this is that we want, one, a blurb about, or actually probably one, here's what to expect to do. 2, here's why it's important. 3.
And make sure that you're connecting it. For us, everything is connected to the real world, and make sure that we are keeping them up there as 21st century learners. We need to keep them competitive, because if we don't keep them competitive, then they're not going to be able to do what some of the other more higher level competitive schools have done. So keep them up there. That way we keep them in the real world.
But Andy, and I agree with what she just said, but also we have a lot of new teachers that are teaching this that don't have a lot of background in computer science. And so having a real world example is a huge help for them, even to kind of get them on the right path. I know when I'm doing professional development for new teachers, if I can't make a connection with them, they are totally lost. So as adults, I think if they're lost, it's going to be hard for them to trickle that down to educating our kids.
Yes, as you go through the cybersecurity tutorials, I think you will see in every one, I basically say, like, for example, in exception handling, on the introduction, I say, hey, have you ever had a web page freeze on you? Well, guess what? You know, the coder who did the web page probably didn't have exception handling working properly. So this is why we're going to look at exception handling. So that's an example, and literally everywhere, that is something we already do. And so, yes, we'll continue to do that. Secondly, what to expect is what we need up front, and then how it works needs to come afterwards. Can I get consensus? Is that pretty much the majority opinion about best presentation for your students and to consume and for you to deploy?
We have a experience. Okay, last summer I ran the summer camp with like 4 or 5 dozen kids in the camp. We have a sim called Smart Cars, right? So what I borrowed is IBD Investor Business Daily. They have like a whole page, several pages of a long article with a lot of pictures, how future smart car, driverless car works, right? So I made copies. I let the group pick different kids, read a paragraph, let them have discussion. So they can visualize how our future would be. And also we will ask some question. So what's the vulnerability of this? So that comes with cybersecurity, right? So, and also you can have those robots. You ask a guy, a boy is running the robots. You give another person another remote secretly, since he's on the same channel. So he hacked controlled the same robot. So how do you prevent this, right? Like today, if you drive a very advanced autopilot Tesla or something, if you lost security, someone hacked in can cause a crash, right? So after all this discussion and newspaper reading, they really, those students become really interested. And the whole week was a fabulous week. It's just, they are just so interested and so zealous to do the project. That's what we have done. So just share this experience.
Okay.
Any question?
And I think giving support, like whatever her name was, said that because you've got new people teaching computer science and STEM who have come from other areas, they need support. They need these Zoom things, these trainings for them to play with it, for them to get an understanding, so it's easier to go back to try to teach your kids.
And so
I have.
Go ahead.
And now I'm a physics teacher, and I just wanna. I come from a different point of view, and I teach math as well. I've noticed one thing that the students are very much like, they need to make connections with what they do in class. So I think that's very important to, like, I understand that learning by doing is very important, but it's very important to kind of make connections with what they do in class as well. And I try every single time to say, like, why does this thing work? And because it has to do with Ohm's law or Kirchhoff's laws and this and that, or encryption with matrices. And I've seen that they really love that when they are trying to make connections with what they've done in math or physics.
Can you see what I've got on my screen right now?
I see a measure tilt angles, right? Inclined planes, you know? Yeah, yeah.
So this is on its way, and notice that we're actually showing here the application of trigonometry for when you're doing tilt control of the robot. So this is a somewhat lengthy and in-depth tutorial where you can actually just do 2 short activities to get your robot up and running. And so for the immediate gratification crowd, or if it's not part of your curricular goals, it's basically you can do 2 small parts. But if you go through it step by step, there's a lot of hands-on to get familiar with, well, gee, you have these sensing axes, and what extent do they align with gravity, and how can we use basic trigonometry to actually go from some kind of cryptic measurement values to the number 45 degrees for the angle that we've rotated. Just wanted to let you know that that's you have a link to it through the slideshow. You can go and take a look, and I encourage you to add comments or
Andy, I'm going to just really jump in here quickly. One of the things I do is I do kind of a code talk at the beginning. And so this is part of our launch. Videos are great, but I try to connect to my students, and I teach middle and high school. So a lot of the verbiage that you're using is over their heads, and it's really, in the weeds. So I try to tell them, hey, give them examples of robots like ATMs, car washes, automatic car washes, vending machines. And I tell them, you actually interact with robots every single day, and their eyes light up, and they always tell me that they don't. And so when I show them what they are and give them the definition of what a robot is, then they're actually more engaged, because now they're understanding that, oh yes, I do engage with robots every day.
Yes. There is some information earlier on. Let's see here, but I think.
So Andy, we've saved a wonderful chat and dialogue.
Can I piggyback on what Jabari said? This is something interesting. We have a sturdy robotics program in middle school and in our upper school, but what happened was that mostly the middle school is kind of half and half, not really, but mostly boys and then some girls. And then in the upper school, the girls are totally gone. And the moment that we are including now in this program something that is related to things that everyone can see has to do with something real, now the girls jump back in. And I'm thrilled. And I don't know anything about robotics. I'm a chemist. And I'm jumping in because I want to support all of these girls. So for me, it's like day and night. Now that they can see that we can do something, and what we're doing is a club that has to do with something that, so we are making our own robots for environmental purposes. And now the girls see it, and they're all in it, and the energy is phenomenal.
Katie, do you want to add to that?
Me? Am I Katie? Am I the only Katie here?
Yeah, you have a lot of experience with this.
I totally agree. I am just +1ing all over the place over here. Excellent point. I am someone who is so excited by all of these topics. I just can't wait to dive into this. But like Claudia said, not only am I seeing like thinking about the applications, like, and she named some of the ones Jabari said, I'm thinking about the people I can help. I had a comment typed out, and I didn't post it, but now I'll tell you. Things that I can wear, jokes I can tell, ways to make people laugh and feel good, jewelry, clothing. You think, oh, those don't matter. That's just stuff of the world. But I'm not thinking about the thing. Don't show me the ATM machine or the broken web page or even the jewelry or the clothes. The thing doesn't matter. I think as the PD provider whose name sorry, I don't know your name, the why, I want to make an LED flash in a particular secret way so that when I walk past your locker, I can't have my cell phone at school. I don't have another way to send a message to you. I'm going to hold my ring by your locker where I know you have a light sensor embedded, and I'm going to flash a message to you that I know you're going to receive when you go to your locker in between classes. Those kind of projects are super cool. And if it's jewelry and I made a little LED ring with that, I have a personal reason. I'm applying your skill, and I'm going to level that project up all day long. Thank you.
So Ken, can you show us the, I'm going to stop my share, I'm assuming you already showed them your Facebook page for sharing stuff like that?
Yeah, actually, Katie might also have something to add here because I asked her what is the best social media tool to use. I've been using the BBC Microbit Facebook group, which I'll bring up in a minute. And are there other resources that are maybe more suitable for students?
Oh, I was talking about for teachers to share the resources like what she made to communicate via the locker.
Oh, sure. Okay. Well, Katie, what's your thought on that? I mean, I see some of that in the BBC group online.
The Facebook group is probably the best option right now. We manage Facebook and Twitter the best. If you post your project to Twitter and tag us, you'll get our attention so that we can share it back out. We don't have a good solution for that just yet.
It's funny, and here us having been around for 30 years, the platforms keep changing and some get old and some remain relevant. But one that's good with Microbit is the BBC Facebook group. I don't know if you manage this, but I put all of my material here before it goes to into various other places. Okay, so I think we should probably move on. If that's good. This is wonderful sharing, and it's great to have the recording as well for us.
Yeah, thank you so much for the input. We'll, as we make successive passes on our tutorials, we'll essentially incorporate the items we discussed today.
And then here is the BBC Microbit Facebook group, and there's a lot of good stuff on here that comes and goes, mostly with block programming, but I've been putting more Python material here lately. Also, since you are all in this class now, you're part of our ecosystem, you will receive our email updates. So you can't easily walk away from us. We'll keep presenting everything we do for the Cyberbot back to you. So it's time for our award ceremony and then final wrap up. Here's what we got. We have 3 prizes, and we'll let the winners choose what they want. They can have the QTI line follower kit, which lets their Cyberbot follow lines, or the ultrasonic sensor with the servo on front, or Simon's book. I like all of them. So briefly, and there's a lot of stuff in here, too much to see all of it, but we'll give you a super high-speed run through. One classroom that was closed down due to COVID, the teachers created this sign unrolling, which I thought was pretty creative. Y'all able to see that? Is that video working?
Looks good.
Okay, cool. So very neat. Susan had this project. It was pretty cool. There are a lot of these. They came in with this integration of light and infrared, or light and whiskers. So her robot rolls around, bouncing off objects until it found a dark spot. And you can make classroom activities, classroom challenges like this really quickly by bringing out halogen lights, opening the blinds, whatever. So there it goes, that robot's parked. Then there was this one, and this was something only I discovered this week, and Andy had to tell me why it didn't work, but it's the same code. And in the second example, the difference is the Cyberbot module is brought in, which includes the Microbit module, but it didn't work. And the reason is, as we explained in email and a couple times, is that the Microbit communicates with the coprocessor, the propeller that's on the board, before it runs all that code. So you probably wouldn't be using the Cyberbot module on a Microbit alone, but it's one possible pitfall.
Well, and I want to emphasize, if we could go back, just make sure that if you're using your Microbit without the Cyberbot, don't try to use from Cyberbot import star, because this statement has to be only in a program where you have a Cyberbot board connected.
And this is super common, and these are submitted in various categories. I mean, or no category, but what's wrong here? And it's super typical. Your code has to match your circuitry, and everything has to be just right. You're combining electronics, power supply, coding. What could possibly go wrong, right? And in this case, Tom just had not properly wired the I/O pin to the correct whisker. So everything looked good. Thanks for throwing yourself out there, Tom. And here's Randy with his coworker. That looks like a very useful dog. Oh, geez. And then we saw a lot of this, a lot of expansion of the Cyberbot with additional breadboards and circuitry placed on front. I think the Cyberbot, you might run out of memory before you run out of space on breadboards, but it seems to be like the breadboard's a good match here. But sooner or later, things want to grow. Here's a big fail from Dr. Rubenstein. He threw himself under the bus. Just couldn't figure. You can say whatever you want about this. Talk over me if you want. Yeah, what is the problem here? The Mac thing wasn't working. Was it the inclusion of the library switch position code? Whatever. Well, his batteries are not in.
Yeah, what happened was I had to take the batteries out in order to install the holder on the Cyberbot on Monday night or Tuesday, whatever. And I neglected to put them back in. Since I was comfortable with the hardware, I just ignored the hardware and went ahead and figured everything that was going wrong, which was nothing was happening, was due to the fact that the Python wasn't working. So I kept repeating and over again, reinstalling, changing computers, and as Einstein said, doing the same thing over and over and expecting different results is insanity. I said, well, what other options do I have? And then I saw 5 batteries laying on the desk and said, oh, why don't I just change out with the spare batteries that I have here, turn the machine over, and as you can see, there were no batteries in it. Put the batteries in and everything worked out fine. Oh.
You were looking for the wireless option for power.
Right.
Here's another one of yours. This is your wife waiting for the Parallax class to end. Sometimes just takes forever. Another coworker.
It's solar powered. You don't need batteries, just use solar power.
Yeah, solar power. It's a good idea, to Charles' son. And here was an interesting one, roaming with infrared. Just, some small turns. You can see it detects really about like a foot out. Good job, Jerry. And then Tom had this one. This was a light following. Good example. And what we could tell you about this kind of thing is if you open the blinds or the door of your classroom, if we return to classroom, the robot will always go towards the natural light. And no amount of artificial light source seems to be able to fight back. So you see it veering towards that light on the other side when it doesn't see the LED flashlight. And then another auto parker. And this is a big deal for Becky. Good job, Becky. And then it plays a song. I'm not sure if you hear that, but she worked really hard on this. This was a huge win for her. And then Cecilia too. Again, it's about the steps forward for Cecilia here. And we appreciated the Instagram shout out.
Right in the garage.
Yeah. And here's a nice variation. Did I cross up the names here? Is this really from Richard or is this from Robert?
Robert.
Yep. Sorry about that, Robert. So what he's got going on, and you can describe it if you want.
It'll wait. It sees an obstacle. It'll wait a couple seconds to see if it'll move. If it does move, it continues. If it doesn't, it actually goes around, and it has the IR sensor on the front and side, so it knows how to make its way around the obstacle.
Yeah, so he's got the IRs on the right side, so he's basically doing a wall follower. You can solve a maze this way too. Some mazes, if they're designed for that. So when you create classroom competitions, think about how it's going to work. So the losers and winners, and sometimes the losers are winners in this case. What do we got here? So, and I think, again, cross up the names. Sorry about that. We got the servo switcheroo going here.
Always a fun time.
Yeah. A lot of lock nuts to remove and replace.
What happens when you don't pay attention?
Of all people. And this is a lot of work to fix this too, but we suggest you use the lock nuts. Otherwise, the nylon machine nuts will rattle loose, and many teachers have their students tear these down and rebuild them each semester.
And Ken, I feel like that previous picture was a good graphical representation of NYSERC and Parallax side by side.
Yep, here you are, and here we are. We'll have to decide it in a contest someday.
A battle of wills.
And this is a good loser too, and very commonly done by students. And you'll see either your battery pack heating up or your motors will heat up when you do this kind of thing. This was really cool. Corey's son, so just a 3-year-old, and this is neat because like I said here, this little guy understands that this is not like one of those toys you just jump on and push it along and wind it up. He's like, this is really interesting, something different here. It's all this electronic stuff. Here's how I use it. Look how quick he just learned. And I like this because he's learning by doing. And he's just waiting for his dad to program it with something else.
Hi, that's me.
Hi, that's me.
Hey, good job. That's you. Do you like the robot?
Yeah.
All right. I mean, imagine that when we were kids having something like that. It would have been amazing. Now we're moving into like the ultra winner circle. So Jackie worked all day yesterday, running into memory limitations, redoing code. So she's got this dog Sunshine that she's able to train a little bit. I think this was her second attempt. And I think the first time he really did this well. So you see him hit the whiskers with his nose. Just have to watch that again. And so apparently the treat cycle caused a little overenthusiasm, and we didn't get to see the third video. Is that close, Jackie? And
yeah,
then
that was close.
and you obviously have 3D printers at home, and so you made this carrying handle for your robot, and you also put some WS2812 NeoPixel LEDs on the top. Okay, not your video, but we'll get back to it. This is Twinkle Twinkle Little Star running in Tom's robot. And oh, here we are back to Jackie's robot. This is cool. Do you guys hear this video, by the way?
No.
Okay. You want to talk us through it?
So yeah, it's a light-seeking robot. So you can see it making short veers to the direction of the flashlight light. The video stopped. There we go. And then now it's the whiskers. And when you press the whiskers, it also gives you an indication which way it's going to turn after it backs up with the LED lights on the top. So it's going to back up and turn to the left. And on that whisker, it's going to back up and turn to the right. If you touch both whiskers with the card, you get a long back up and then a turn to the right.
Maybe you can add some weight on the front of that robot too.
Yeah, it skips around a bit.
Okay, so yeah, our winners then. I will contact you outside of this, but we got, yeah, Robert, Jerry, Corey, and Jackie, and Thomas. So I went a little bit over on our promises and could not make decisions, so I awarded more than I should have. Finally, now as you guys go forward, as I mentioned, you're in our email communication, so you'll receive email from us about what we're doing and classes we're running, et cetera, and tutorial editions that we make. Sometimes that email does not distinguish between commercial customers and hobbyists in education because we have a wide variety of users. So I just ask that you sort out what is good for you. When you go to purchase these things, if you go that way, there are a couple ways to do that. I think these prices are just a little bit outdated, but Cyberbots run around $200 each, and we sell them alone, or we sell them in these 12 packs that include all of the parts for the main tutorials plus the project. So This is like the box of fireworks that you always wanted, the super expensive box, but it'll keep you busy. Unlike the fireworks, this will keep you busy for a whole semester because it has all these infrared remotes, line followers, ultrasonic sensors. So even a classroom banner to work with, to put up. So there's good stuff in there. And yeah, when Kate contacts you, just tell Kate if you're going to do this or not. And we do not at all do any sales. We just try to keep track of our metrics so we know if we're productive with everything we do. So if you're using other robots of ours, you can convert the Bobot and you can convert the ShieldBot as well quite easily for a low cost. You can turn them into Cyberbots, and the components are largely reusable everywhere. There is this Educator Hotline. It's been ringing this morning during our class. It's a great way just to get your questions solved. One thing we know, and one thing you're paying for here when you buy these parts is support, and you've got to have it. We want you to be productive, and we want you to be a success. I also have my preliminary CTE credential, and I know those loser days in classroom. So someone's actually calling right now the Educator Hotline for fun because they saw the number. I know what it's like when things don't go well in class, and we don't want you to be stranded. We want you to tell us what we've done wrong, how to get you out of a bind, what's changed that you don't know about. Call us and tell us. And this rings straight through to my phone. And unless we're doing a presentation like this, I'm answering this and making sure you're not stranded. So use it. And by the way, a portion of all the Cyberbot sales go right back to the Cyber Innovation Center too. So we just return those, a good chunk of those funds right back to them so they can keep innovating with us. Parallax is in Rockland, California. You're welcome to visit us anytime. And NYSERC is in Bossier City, Louisiana. So with that, we conclude our 3-day fun. And any questions, comments, we can take them for 10 minutes. Otherwise, I just want to say thank you so much to everybody for contributing this week. It was my favorite class so far, and you are now the 400th teachers we have reached in distance learning since March. Can you believe that? And I prefer this model. Yeah, you're very welcome.
Well, this probably works well for you guys in the sense that you can get teachers who can be in disparate locations to actually participate in this.
Our energy and our money goes much further, and we'll take it. I don't think, the problem is when you all return to school, we can't get you in these kinds of classes. So we end up, that's really why we traveled. Usually when we do PDs with districts, you are out of class for a day and you're able to attend, or 2 days. But we don't know if this will work in the fall when you return to your regular routine.
Well, it was nice to be able to do it since we're all in this situation. So
yeah, I would agree with
we
that.
wouldn't have gotten the chance to do it if we hadn't been. So actually worked out. Yeah,
it worked out right around my classes that I'm already in summer school with.
This is a great training. So yeah, this is great training. I have done robotics teaching for the past 5 years, but based on Lego and Arduino. So right now, since my own son, actually he has done all the line following, you know, automatic parking with EV3. He's really advanced. He's a teacher himself. And I have a group of, children. They all grew up like him. Many of them been with our program for several years. That's why I don't want to lose all those bright kids, right? That's why I've been searching what's more advanced. And I tested Yaboom or the other products. So I really like your Parallax with this 3 days training. So I'm so happy to know your platform. This is a whole solution. If you can allow, I can share a very brief, quick video. Can I?
Yes, you can.
Okay, can I share screen? Okay.
I think we just need to make you co-host if you can't automatically.
Okay.
I think screen sharing is available to everybody.
Okay. All right. Okay. You see this one? Okay. Share. Okay. You see this one? This one is what my son and me and a few kids, we built this robot together. Okay, and this robot is a Mindstorm EV3 from Legos. But right now, all these kids, including my son, especially, they all are grown with a Mindstorm. So that's why I need something more advanced.
Yep.
Yeah,
So,
the Cyberbot gives you an opportunity to go a little bit deeper. For example, in Legos, you have a bumper block, and in Whiskers, you have essentially a learning experience about what's inside the bumper block and how it works.
And Charles, you can take the board off the robot too and connect it to motors outside of the Cyberbot and sensors. And I want to encourage people too, the low-cost digital and analog sensor kits you find on Amazon, they go well with this, especially if they are high-low type signals or analog output sensors. So now you can easily use them with electronics.
yeah. So with your platform, all of this Python right now, the most popular language, I'm so happy I found you. And this is really good for kids are older now, so 5th grade and above. So you see like that video shown, that robot actually is a program automatically can find, if you make several people make a C-shaped ring, right? It will stop in front of you, find where's the exit and go up. Also the arm actually move up and down. We put a bell in front of it, program it to turn the upper body to play Twinkle, Twinkle Little Star song. So that both arms will hit on the bell. So we have done that, but to do EV3 for 5 years, that's enough for me. I'm kind of, also my son is from like what, 6-year-old to 11, all these 5 years. A group of kids like him, they are older. I need to give them something more advanced. That's your product.
Somewhere to go.
Thank you very much for including me in your training. I
You're very
can't
welcome.
more to thank you.
Yeah, well, we really appreciate you joining, and your positive attitude. It encourages us. And really, our currency is enthusiasm from our customers. And that's why we've been at this for so long.
Hey, Ken, I also wanted to say for anyone that's wanting to continue on with these kind of online learning experiences, that Parallax is putting on other workshops just like this. If you want to come back and revisit to kind of seep in the information one more time, if you didn't retain it all, you want to come back and revisit that. There are other workshops in the summer, and then NICEARC, we've also got a series of workshops going on. This week, Joe and I have been doing a Linux introduction to the command line. We've got cybersecurity workshops on the NICEARC cybersecurity curriculum that we just went live with. So there's several different opportunities to keep learning like this, and we're probably going to continue doing them throughout the school year, I would imagine, especially since there's so much uncertainty about, that I don't think everyone's going back to the classroom. Some schools are, some schools are not. So it's probably going to be easy for us to just continue doing online stuff going forward.
Well, I signed up for August. And
Oh, good.
Made sure this time Kenneth gets me my robot.
Yeah. Well, if you filled out that form, yeah, we shouldn't mess up. And I know you got one on the way.
Cool.
And also, since we put so many teachers through this class, we're planning an advanced Python class with the robot in the fall. Yeah, so we'll want you there too.
Well, just keep emailing us. This is great.
Good. So glad to have you.
Just so people can see, I mean, here's an example of some of the other sensors that I added on this one with the line sensors.
And those literally like $1 or less each, right? From Amazon.
Yeah.
And they have a digital
really
output,
cheap.
and they have a potentiometer on them for adjustable gain.
Yep.
Yeah, I mean, you can't go wrong. I mean, at that price, you almost can't go wrong. Get a box of these. Sunfounder, you can have all the names that exist, but they're on Amazon.
That's the other thing I play with.
Oh, a LiDAR. Okay.
That's a LiDAR, yeah. And that's actually only a $99 LiDAR. from RP LiDAR.
Wow. So self-driving car projects could be done.
That's exactly what it's for.
Mm-hmm.
Cool.
Hey,
Anyone
Ken?
else? Yeah.
Yes. So, so at our school, we're middle school in Houston, Texas, and we do a lot of EV3 robots. So we're able to get those just, almost at will from Harris County as well. But they're not, most of my kids, it wants to use the that EV3 editor, which is it's like using LabVIEW. It's hard for kids to grasp. I mean, they can do it. The more advanced kids can do it, but the lower kids, they just don't get it. So it looks like your platform is going to be much better for them to be able to do. And I want to see if we can get more in depth into it.
Does someone else out there have similar experience to that with the EV3 versus this Python? You're the first person I've seen compare them, so it's new to me.
Okay. Right.
What was your other part?
So I want to start to introduce my kids to this platform, and I think it's going to be much better for them. So how do I get access to your other trainings?
Oh, okay. So I'll paste a link in. The next one coming is in August, and it's a 3-day. And so you'll be notified of everything we're doing because I have your email address.
Okay.
And that's how you got here. But what you could do is go sign up for this one that I just pasted in the chat.
Okay.
And sometimes you can even sneak another robot out of us if we're not paying attention. But take the class again.
Okay. Sure.
And pretty much you're part of our system. Everything we do, we'll share back to you. And sign up for NYSERC's curricula access as well. Tommy, paste the link in there. So
NYSERC's.
Yes.
If you haven't used NYSER yet, I've been using it for 2 years, and it is amazing.
Oh, yes.
It's amazing.
Your check's in the mail.
Thank you. They have a science DNA one that fits perfect with my 3D printing project. So my kids can actually create their DNA project, but instead of using the candy, we use them making the little 3D parts to actually make the DNA monster creation.
Oh, wow. That's good.
It was cool. I mean, it is amazing. We got introduced to it 2 years ago, and I haven't stopped using it yet. It fits everything.
Demetrius, had you heard of NYSERC prior to today?
No, I have not.
Okay.
Well, we're neighbors. I'm up in the Woodlands. I need to come down and hang out with you sometime.
Oh, really? Yes, we absolutely need to do that.
And Charles is my neighbor too. I just discovered. He's up here in the Woodlands also. I was also going to say that if you want to continue to find other PD opportunities to follow social media, NYSERC, I know we put our content on social media. Parallax posts their stuff on I know on Facebook. That I'm really active on Facebook and occasionally on Twitter, but follow Facebook. We put out blasts for that kind of stuff. I've been over the past year, I guess, I've been really active in the Cybersecurity Educators Facebook group. Cybersecurity Educators, it doesn't really focus on any of the robotics content that we've been doing here, but a lot of good free PD coming out of that. Ken's been what's the name of is it the Blockly for Parallax? Or?
Blockly for microcontrollers.
Yeah. Blockly for microcontrollers. It apparently is not just, people don't see that it's just for Blockly. All sorts of different microcontroller projects coming out of that. So you can find all sorts of good resources like that following us and Parallax on Facebook.
I think the big step for Demetrius then, it sounds like you're going from more of a black box to electronics and more expandable type hardware is where you'd be going with this.
Right.
And did you say you're middle school?
Yes, I am.
Okay. Yeah, so I found the content in general, what teachers tell us is this works in middle school with the right teacher and the right interests of students, but it involves a little more instruction and a little more effort from all. So you can certainly do it. It's become a larger percentage of our total use. It used to be what you're using right now would be used in university level 10 to 15 years ago. And it has steadily dropped now to middle school. I never thought this would happen, and the middle school may have been pointed out early, super important for the girls. When I was teaching locally for 7 years on and off, every one of the girls in the middle school class carried on to the high school engineering tech class. And if they didn't have that exposure, they were so much less likely to take it in high school.
That's what mine did. Mine were the first place winners for the Lego EV3s 3 years ago. And it was an all girls team. And all of them went on to engineering, robotics, and biomedical.
Yeah, so the important role, the middle schoolers they're the career makers.
Yep.
Really? You really, truly are. It's that exposure.
Our tech center always is asking, our career center constantly emails me about what girls do I have that want to do engineering. And we do a big day and make a big, huge thing about the girls rule. My principal even said it one year. He said, he didn't say things often, but he said, my girls ruled.
And I have to admit, with robots like this, they're a little less interesting to girls. I've just seen it. It's a business fact for us, but also a reality fact. So you got to do what Katie's demonstrated earlier. Follow her on Twitter.
We have
to do that.
We have run robotics for 5 years, huge camps. We are not a non-profit organization, actually. The thing is, we get a 10 to 30% enrollment from girls every year. And in order to attract girls, we offer the program on different weeks, right? For example, when you do like smart cars or Mars mission, you have both girls and boys. But when we have like a robotics in the garden, right? Robotics in the kitchen, and the robotics with arts, right? We have more girls coming. And I have to see this right now in this meeting. I'm sorry, there are more men and women. I don't want to insult any man, but we have observed as a reality, either you don't get the girls, but once you get those girls, even though they are the same age like those young boys, they are more dedicated and focused. Boys, they like to build a robot quickly, and then they run out of battle. They are like in the sports mode, right? But girls, they are there to dive deeper. They spend more time to really do very, very deep research, and they expand the project. So their nature of their maybe personality or the nature of a girl turns up in our camp. They got our top awards. It's not we are biased. We purposely try to reward them. They really earned it. So they beat a lot of boys in their project. We do our camp like project driven, right? And end up their robots is better. They can achieve more. They understand more. So that's why if you want to attract more girls, you need to think about what they are interested in, like robotics in the kitchen, gardening, or arts. You mix those.
Maybe arts would be for us. But I find
but that's true for women all over.
Right, but what I find is that our girls are just not interested in anything that has to do with engineering. And that's the biggest problem I have. We're really trying to pull them in, but they're just not. They're just
Don't call it engineering.
No.
Demetrius, I got another tip for you. I just pasted in the chat the make it code it. So before you even give them the Cyberbot stuff, don't even give them the robot. Just give them the microbit and a cable. And you can go to this website that I pasted and then select topics that are totally non-robotic, but they relate to music, physical education, sciences. Did you see that link?
Yes.
Okay. And if we had another day, like I'd talk about my ideal way to roll out a class, because Parallax is only a piece of it, really. There's so many things around it and ways to encompass it on both ends. But here you can do non-metal looking rectilinear robot shapes. Instead, take it to the environment, music, physical education.
And another thing that'll help you, Demetrius, is that, or anybody trying to get the girls in there, one, I have an advantage because I'm a girl. So they think it's really cool. Get a girl helper or a mentor. Okay. The other thing that works for me is once I get one girl in there, girls like to hang out with girls.
They swarm.
So you get one and then she'll go get every friend she's ever had in her life. And
That's right.
That's how I went from, my program has always been more boys, less girls. Well, I talk up my girls all the time. I tell them how great they are, how #1 they were, how they took first place. Next thing I had, I've got half girls, half boys now. For my 6 classes.
Yeah, and especially if you do things like the neopixels, you know, like the neopixels and, you know, colors and music and art, along with just that little bit, and you can show them they can do that. That really brings the girls into the programs.
Yes, but I would recommend, Robert, you concerned me a minute ago when you said don't call it engineering, because don't dumb it down for girls. The very few, but the very few I've had have been my hardest workers.
Yes.
But Laura, you're very blessed that just being a woman has worked out for you.
Yes,
I am still getting all boys. And one of my first efforts was, well, let me do a Girls Who Code club. So it would be after school, and show them how great this is. And then, Robert, you did touch on this. Let them see that, yes, you can do it too. And on the last day of our club, as I'm escorting them to the pickup to go meet their parents, they're like, Miss R, are you doing this again next year? I'm like, yes, definitely. I sure am. Their response was, great, then we don't have to take it as a class. And I went, oh, no, not the plan. But we talked about this way earlier today. They have to see that it's relevant to them. And I'm in Houston also, so shout out to all the Houston people. But if they think of if they think of engineering as only oil and gas, they're not interested in that part of engineering. So I really talk up Engineering Week, which is a national, I don't know if any of y'all know that, but Discover E. I do Engineering Week, bring in speakers and projects and stuff. And then I've had a woman transportation engineer and a woman civil engineer. I said transportation, I meant traffic. Civil engineer. So I try to bring in more people. But right now, that's only being seen by the people who are currently taking my classes. So I have to work on admin to kind of
I'm going to put my 2 cents in here. I have been teaching middle school and high school computer science now for quite a while. And the one thing that's helped me the most has been working with, and I put it in the chat, the National Center for Women in Information Technology, or NCWIT. I have students who I have sign up for their Aspirations in Computing awards. I had a national winner this year for the first time. And that's created a culture of girls who have been given the opportunity not just to sort of show off what they can do, but to be given specific sort of support and mentors, and understand that this is a world that's not easy and that there's all sorts of challenges. But NCWIT also does a lot to educate, for those of you at schools, to educate your counselors to understand how they're avoiding sort of driving girls into these professions and these disciplines. And so that there's a lot that can be done institutionally. And I feel like I've been swimming against the stream for many years, just because of the culture, but also because of institutional sort of structures that stop girls from signing up. They're told you're better off in English class, or you're better off doing this. And so we really have to like expand that. And that's a great organization with, like, I have women mentors who come to my class from NCWIT. They've been willing to get leaders in the tech industry. I'm in Utah, and they come to my class, and they come on Zoom, and they're a big part of like the face of my class, because my face is not like attractive for girls to, not, you know, in general, but, you know, to come into my room. Like, I work really hard to get that to happen. And I can't do it just by having Star Wars posters and robots and things like that. You know, I have to really work hard to make it an attractive space. And so that's just my push. It's been a big part of what's made it successful for me.
And I'd like to chime in with that as well. I have now in Colorado, I have at least 2 or 3 girls that win state awards every year. I'm still waiting for that national winner. But I have a young lady who got a high-end basketball scholarship this year. But the first thing she mentioned when she had her quotes at the end of the school year was her state award from NC WIT. The other thing we do is I do an after school club that basically all I'm there is to turn the key in the door. I have IT people, but I have engineers from Northrop Grumman, Raytheon come in. I've got the NSA that comes in. They're close to where we're at. And then we're starting to work with Lockheed Martin. But I think the really cool thing is the more you do this with either gender is that I now get at least 2 or 3 visits from the NSA or the FBI every year. But it's for security clearances for former students. And I've got one young lady who was one of my favorites a few years ago. She now teaches how to fly Black Hawk helicopters. So pretty amazing. And I was just going to shout out to Tommy, and this is my favorite NYSERC project is the working basically Enigma machine. And it's really a great way to introduce it because then they can take this and they have to create messages. And it's really a great time with kids. They really like that.
That's a freebie that you don't even have to have access. If you go to nyserc.org, I think it's /Enigma, use a Pringle scan. And this is an Enigma machine about to become an Enigma machine 2 weeks or something like that.
Hey.
But it's a free little color print off thing that you do, and little PDF. We have that, and then we have been working with the Virginia Department of Blind and Visually Impaired, where we use the Parallax Bobot to teach blind and visually impaired students programming. They loved that. And then when we were trying to think about how can we do the Enigma and make it tactile, one of our colleagues, Matt, created the 3D printed model that you just saw Randy hold up there. And the lines on that activity are raised, and then we have kind of embossed letters on the sides there. There you go. You can see a little bit better. So that's a fun little activity. That one's all held together with a rubber band in the middle. The ends are kind of threaded on there, and yeah, there you go. So it's a cool way to introduce encryption with some historical context behind it, and kind of talk about the need for computing power. That was really what gave the rise to the digital computer. And so by suffering through building an Enigma, you start to learn, man, I really wish I could do this automated some way. There's your impetus for programming. The robots give you that handheld manipulative for your programming logic. And that's another good gateway to getting kids interested in programming and whatnot.
I had a kid actually who was way ahead of everybody else. I said, okay, now go program. 3 weeks later, he said, I ain't got a clue.
We do have a little Python script we could share. If you contact us, we can get that out to you so you can, whack out a whole page of Enigma encrypted text, and then they'll keep kids busy for years.
Can we get your email, Tommy, so if we specifically wanted to
Sure.
ask about that?
Yeah, I'll put it in your chat.
Cool.
You're all running the classes that students will remember.
Yep.
So speaking of resources, I'm very active in the IEEE, the IEEE, and all of you have local IEEE members, local IEEE women in engineering members, and student branches at the various universities that if anyone's interested, I will do my best to get you in touch with the appropriate folks. Obviously, face-to-face is going to be an interesting kind of thing in the fall. Otherwise, I would invite you to do some sort of a face-to-face or technical what have you. But we've been doing with the Boolean girls in Washington, D.C., workshops for girls between, I think it's 8 and 14. And we were running like crazy doing them throughout basically the northeast of the US, and then COVID hit us before we were able to actually expand it. But we're hoping to have several Saturday weekend sessions for the the girls and having them in Ohio and in the greater New York area, et cetera. But that has been postponed until we have the ability to have that done. That was one of the other reasons I was interested in how the Parallax robot was going to be cleaned in between. Right now we're using Lysol wipes, and I guess we can include the alcohol also. If you want to contact me, I will put my email in the chat. I'll give you my Pratt email because that's shorter. Otherwise, it's c.rubenstein@ieee.org. Great meeting everyone virtually, and looking forward to chatting with you in the future.
Yeah, likewise. Thank you. So with that, I think we'll wrap up. And
Yeah. Hey, Ken.
Yeah.
Everyone's been like it's been hard to jump in. So I got a couple comments on the middle school piece.
Okay.
So like for all of you that are running EV3s, if you want to get girls involved, you got to get rid of the Legos, because little boys have so many Lego kits at home that you take a box of Legos out, forget the robotics, but you'll leave the girls in the dust with Legos. So this year I actually gave away all my Legos to our elementary school. I'm a middle school teacher. And I've jumped in with Erector Set, which is actually a toy that I really wanted when I was 9 and 10 years old, but I couldn't get because it was only marketed to boys and nobody would buy me a toy that was for boys. So now I have a class set of Erector Sets. So what that does is it levels the playing field for boys and girls building and constructing. Before the Erector Set, I noticed in my classroom that we do a lot of invention with cardboard and paper. And the girls have much more manual dexterity. They have much more capacity to plan ahead. And they're very, very good at construction in general, speaking relative to the boys. So if you do invention first, you're gonna get the girls hooked. And just make sure you have googly eyes and colorful things to decorate with, because sometimes that's a student's favorite part of a project, even after doing all the hard invention stuff.
That's right.
So that's my take on middle school girls. My question for Parallax is, so I learned Python during remote learning this year. That was what I did earlier in the last 10 weeks. And this was like a perfect extension for my personal learning. I see a couple of students in my class that could get here, but what I really need is, we have microbit, but I haven't really even explored this deeply enough just standalone with my students. So I know block coding is the place to start, but what's the bridge with Parallax to support block coding a bit more? Because I believe the propeller is only programmable with Python, is that correct?
Propeller's programmable with block coding and C.
Okay.
So are you thinking of a bridge between block coding and Python on a robot? How to get there?
Yeah, because I think this is a pretty hefty jump for a middle school kid who's been block coding microbit only and block coding, for instance, Sphero robots.
Okay. Did you look at the Make It Code It site?
Yes, I'm familiar with it.
Okay, does that give you that bridge? Because you can choose you can choose block or you could choose Python.
Well, actually now, just with today's release, yeah, Python is fully available.
So this is brand new, and I just want to show it just for a second here, if I could share screen again. I've played around in here quite a bit lately, and I like this.
Python is so popular. Even Legos is about to use Python to code the EV3 Mindstorm sets now.
Oh,
now, where is that link? And let's see, maybe it's right here. Oh yeah, this is it. So this is what I thought was cool. So for Dimitri's question, here's all your non-robotics entries, but you could basically choose a language, make code or Python. So let's just take this this badge here, and what they added that's really cool is this. So here it is in make code, and then here it is in Python, and you can open this in the editor and download it from here. So there's your code in the editor.
Okay, awesome.
Had you seen that?
You know, the Python piece isn't that fairly recent coming in?
This just came in a month ago. So yeah, I don't think very few teachers have seen it. But they also have this classroom tool where you can share out your code with them.
Yeah, familiar with that.
So I would do this kind of thing before I got into the robots.
Beautiful.
And then to carry it further, we have a little $5 adapter we're putting out where you can breadboard with the microbit, and you can do LEDs with the microbit and servo motors with the microbit without the robot in the way. And that would lend itself to a lot of the art type projects too.
Yeah, I call them like 3D puppets, sort of.
Yeah, that exactly.
Desktop things.
Yeah, and Katie from Microbit, again, back on her Twitter, is loaded with that kind of stuff.
Thanks for that bridge. That's perfect.
Sure. And I want you to meet your counterpart on the North Shore at Lake Tahoe School. Her name is Heidi Verkler. She's just like you.
I lost my people screen. There it is.
So anything else here?
I had to jump out for a second, but wanted to come back and just thank everybody and Ken and make it really clear, if it didn't come out before, how incredible this workshop has been. It's hard to run something like this in person, and running it so well virtually is a huge testament to your ability to think about others, care about others, and work tirelessly for teachers and for their students. So thank you, Ken, and thank you to the whole NYSERC and Parallax team. Really, really enjoyed this.
Thanks to all of you.
Yeah, you're so welcome. And Katie and I have chatted how to really expand this kind of concept, but we've just decided to get this kind of figured out now, and then we'll decide what to do with the fall. But thank you, and appreciate your help too. It was a lot of fun for us, and like I said, we prefer this over traveling.
I'm with you.
Right.
I'm with you too. I'd rather do this than traveling. So
you don't have to carry all those robots around with you.
There ain't a problem with security, but it's just that the time consumption is a day on either side getting anywhere you're going, and a different lab every day, and this controlled environment.
You don't get to go home between them.
Yeah, that too. I lost a lot of time in the last 20 years traveling, I would say.
And it's always fun on the East Coast. You start teaching at 8 o'clock their time, and it's 5 o'clock our time. And,
and poor Andy, he's arrived in Maine, late at night, then gets sick on the airplane on the way there, and then still had to fumble his way through classes at the farthest eastern city and survive. This happened to us so many times.
That was quite the adventure. Or, a blizzard comes in, there's beautiful weather one day, and then you get a blizzard the next. And
Okay. Wrapping up then.
Well,
awesome.
All right.
Thank you, Ken. Thank you, Andy. Thank you, Katie.
We'll see you all online and in the future.
And thanks everybody for your feedback. We're really looking forward to incorporating that into our material.
Bye now.
Yeah, thank you.
I'm really looking forward to getting into deeper stuff in this. And Ken, please let me know when the Propeller 2.
You're ready. Sign up for the early adopter forum that I linked in. Okay, bye.
Thank you, Ken.
Bye, everyone.